When we take a source C file and compile it into an object file, then we've talked about various things that need to show up in that object file. First, we talked about the machine code that's there, how various C functions and expressions are compiled into machine code. Also, that any global variable initialization needs to be there. For example, if A were not extern but were declared here, we might supply some initial values for the array, and those would need to be somewhere in the object file. We've talked about how the defined and used symbols need to be there. For example, the fact that getC defines get underscore A, and that it uses A, expects it to be supplied by other objects. Debugging information goes in the object file. If we compile with -g, then we get more debugging information. But even if we leave -g off, there are some names for functions so that the debugger can tell us where we are. And also we saw that there's always backtrace information. In case the compiler does not use stack frames, there's always extra information, unless you go well out of your way to suppress it, to tell the debugging tools how to reconstruct the stack information. There's all of these things. There can be more things. There could be things that we will need in the future in object files that are not there currently. So there's a variety of information that needs to go in there somehow. When we take that object file and link it with other objects to create an executable, then what goes into that executable? Well, again, it's the machine code and global variable initialization. In fact, pretty much everything that's in an object file needs to be in an executable file, or might be useful there, like debugging information. And there might be things in an executable that are even more needed, that aren't actually in an object file. Or if we compile, if we rather link that object file into a shared library, then it's the same sort of information all again. So since we have this large set of information, and since it's extensible and similar among those different formats, they all use the same basic file format on Unix variants. And that format is called ELF, Executable in Linkable Format. Not all Unix variants use this, but it's the most common. And it's mostly used for object files executables and shared libraries. So we're going to look at all three categories, all three variants of ELF files. An ELF file format is kind of a generic container, a little bit like XML. XML defines certain rules, but it doesn't say what the things that you put in XML are meant to represent. There's some other layer that says particular tags and attributes will be used. Similarly, ELF defines a particular layout for the file format and how to find information, though it's more specifically tuned to the problem of linking and loading, hence the name. So it'll have specific notions of addresses and file offsets that are built right into the format, but it's also extensible in that new kinds of things can be added to the file, whether or not they were anticipated before.